Hello, everyone. I am sorry that I have to be gone today, but the soccer team is out of town and I am with them. So we're going to have to get along with the recorded lesson. Yesterday, we started chapter 2, which is on solving inequalities. The benefit is a lot of the steps that are in this chapter are very similar to the last chapter where you're solving equations. So if anything, this is kind of like chapter like 1 plus, just one extension. Yesterday, you did sections 2.1 and 2.2. So have your homework out. If we need to pause the video until everyone has their homework out, go ahead and do so. Otherwise, I'm going to continue forward, assuming that we are ready to go. So the 2.1 answers are right here. This section was mostly on translating and just graphing answers that are already supplied to you. So the first section shouldn't have been too bad. 5 is x is greater than 3. 7 is 15 is less than or equal to t divided by 5. 8 is 3 times w is less than 18. 11 is 13 is greater than or equal to v minus 1. 16 is not a solution, doesn't work, not true. 17 is a solution, it's true. 21, yes, is a solution, it's true. 30, you're graphing, I don't know what the variable was, but it's less than or equal to 5. 31, you need the values that are just less than -1. It's an open circle because it's not equal to -1. 34, you want the values that are less than +1, open circle at 1 because it cannot equal 1. 41 is x is less than or equal to 4, and 44 is x is less than -1. 2.2, there were only 4 in this section that you needed to do. We used to do these 2 sections over 2 days, but then students shared that they felt they could do it in 1 day, and they were right. So the problems that you had to do were 9, 11, 15, and 23. So 9 is m is less than or equal to 7. 11, r is just less than 1. Did I say 9, 11, 15, 23? Is that right? Yep, 15 then is h is greater than or equal to 8, and then 23, the original problem is n minus 9 is greater than 4. If you solve by adding 9, you get that your value n has to be less than 13. Any number less than 13 would work, so 12.99 or 5 or -4 would all work. So there are your answers to 2.1 and 2.2. Just as a little warm-up, and in case people were gone yesterday, I would like you to try these 2 problems at the bottom of those homeworks. I will check those homeworks for credit tomorrow, but you hold on to them today just so that you have the answers for them and can use them on our quiz tomorrow. So for the warm-ups, I'd like you to check whether 6 is a solution to each. When you substitute 6 in for x, do you get a true statement or a false statement? So pause the video now for maybe a minute, unpause it after a minute, and everyone's had a chance to try, and we'll see how it went. Just giving a little review of what we covered yesterday for anyone that might have been gone. So here's how it works. Like I said, you take 6, substitute it in for x. If I put 6 in there for x, I have 4 times 6 is less than 20. I get that 24 is less than 20, and that's not true. 24 is not to the left of 20, it is not less than 20. This is false, so you'd say 6 is not a solution here. It gives a false statement. What if I put 6 in here? I end up with 6 minus 4 is greater than or equal to 2. That is 2 is greater than or equal to 2. And although 2 is not greater than, it is equal to, and when you have the or part, it just needs to be one or the other. So this one works. 6 is a solution since 2 is equal to 2. There we go. That's part of what we were doing yesterday, was checking whether values made true statements. Today we're going to be working on solving inequalities using multiplication and division. So first thing I want to check though is, will multiplying both sides of an inequality by any number change the inequality's truthfulness? So here's what I mean. Let's take a true statement like 1 is less than 3, and let's multiply by a number. If we were in class, I'd say pick any number. Let's say I heard the number 4. So let's multiply by a +4. I might multiply both sides by 4. I get 4 is less than 12. Is that still a true statement? Yes, it is. So if I multiply both sides by a positive, nothing needs to change. The statement is still true. Let's start with another true statement. 5 is greater than 4. Now let's multiply by a negative. I might ask you to pick a negative number. Maybe I heard 2. So let's multiply both sides by a -2. If I multiply by a -2, I get -10, and then I get -8. And my statement would be then that -10 is greater than -8, and that is not true. -10 is not greater than -8. So in order for this to be true, my inequality's direction would have to change. because negative 10 is less than negative 8. So if I multiply by a negative, what happens? Well, it changes the signs of my numbers. This went from a positive 5 to a negative 10 and a positive 4 to a negative 8, but it also changes the sign of your inequality, the direction of your inequality. So if you multiply by a negative, you need to switch the direction of your inequality, because negatives switch directions of things. They take positives to negatives, negatives to positive, and if an inequality has a direction, which it does, then you need to switch the direction in order for the statement to be true. So the takeaway is this: whenever multiplying an inequality by a negative number, if you're the one that's multiplying by a negative, you need to switch the sign of the inequality in order for the statement to still be true. Otherwise, you'd get false statements. So that's how multiply works. What about dividing? Well, dividing both sides of an inequality by any number change the direction of the inequality. So let's start by taking a true statement. 20 is less than 30. 20 is to the left of 30. That is true. Let's divide both sides by a positive 10. If I divide both sides by a positive 10, I get 2 is less than 3. Is that still a true statement? Yes, it is. So if I divide by a positive, I don't need to do anything because the signs of the numbers didn't change, so the sign of the inequality doesn't need to change. What if I divide by a negative? Let's say I have 24 is greater than 12. That's a true statement. Let's divide both sides by negative 6. Divide both sides by a negative 6. I end up getting that negative 4 is greater than negative 2. And is that true? Is negative 4 greater than negative 2? No, it is not. In order for this statement to be true, the direction of the inequality needs to change signs. Why? Because when I divide by a negative, it changes signs of numbers. It also needs to change the sign of the inequality in order for the statement to be true. So the takeaway message is when dividing both sides of an inequality by a negative, you must switch the inequality, the sign of the inequality. If it's a greater than, it needs to go to a less than. If it's a less than, it needs to go to a greater than. With that in mind, now I can solve inequalities. Let's say I have 5 times v is greater than or equal to 45. Well, how do I solve this one step? I undo the only operation happening to the variable. I have 5 times v. How do I undo multiply? I divide. Divide both sides by 5. I end up with v is greater than or equal to 9. And there's my answer. If I pick any number that is 9 or larger, I will get a true statement. If they ask you to graph it, you draw a number line, you put down a mark. The most important number here is the number 9. I put a circle around it. I want all the values that are greater than 9. And then I can be equal to 9, so I fill it in. How can you check? Pick any number bigger than 9. How about 10? 10 is easy to check. If I put 10 in, I get 5 times 10. Is that greater than or equal to 45? Yes, it is, because I get 50. 50 is greater than or equal to 45. That's a true statement. If I pick any number that is 9 or bigger, I'm going to always end up with true statements, which means that they are solutions. So there's my solution set. Over here, I have n divided by negative 2 is less than 4. I need to undo division with multiplication. So I multiply both sides by a negative 2. This negative 2 then will cancel that negative 2. I'm left with n, and I get a negative 8 here. And let's say I don't switch the sign. You definitely need to. This is going to need to become a greater than, but let's say you don't. And this is how you can tell that you did the wrong thing. Let's pick a number that is less than negative 8. How about negative 10? That's easy to check. If I put negative 10 in there, I get negative 10 divided by negative 2 is less than 4. Negative 10 divided by negative 2 is 5. 5 is less than 4 is not a true statement. If I don't switch my signs, I'm going to get all of the false solutions, so the not solutions, which means that I didn't interpret it correctly. So the reason why is because this less than symbol needs to be a greater than symbol. I need to pick all numbers that are greater than negative 8 to be my solution. So I put a number line down, negative 8, my key point, put a circle around negative 8. I need all the values that are greater than negative 8. And do I go back in and shade negative 8? No, I do not, because I want all the values that are strictly greater than negative 8. Let's pick a number greater than negative 8. That's easy to check. I'm going to pick 6, because it's negative 6, because it's divisible by 2. So I get negative 6 divided by negative 2. Is that less than 4? It is, because I get 3. And 3 is less than 4. So if I pick any value to the right of negative 8, I'm going to get true statements, which means I did the problem correctly. So there we go. That's solving using multiplication and division. I'm going to give you a chance to try. So pull out your whiteboard, please. And on your whiteboard, just a little self-assessment, quick check-in for yourself to make sure that you're doing it right before you start the homework. You try these two. So try the one on the left, try the one on the right. You need to solve one of them by doing division, one of them by doing multiplication. So let's say pause the video now for maybe a minute and a half. Unpause it once everyone's had a chance to try. Once you have your answer, maybe check with a neighbor if the video is still paused. So pause the video now, please. Okay, I'm going to go over it quickly. This one you need to divide both sides by a -7. Since it's a negative that you are dividing by, you need to change the sign of your inequality. So this will become v is less than -3. To graph your answer, you put down -3, circle around it. I want all the values to the left. And then I fill -3 in because -3 would actually be true because it would make it equal to 21. Over here, how do I undo division? I multiply both sides by 4. When I do that, these would cancel each other out. I then get x, and I don't need to change the sign of my inequality because I multiplied by a positive. Positives don't change signs of numbers. They won't change signs of inequalities either. I get 12, and anything less than it would make a true statement. So there's your answers to those ones. That's the first half of 2.3, but that's kind of the key part. The second half is going to be translating from English to math and then solving it. So you have all the tools now that you need. This is just practice in translating. So this one says the product. Product means multiplication. So the multiplication of 7 and x, so 7 times x, is greater than, so greater than 49. So when I translate this statement, it looks like this. So the product of 7 and x, I've done in black, is greater than 49. Now I just solve it. Divide both sides by 7, divide both sides by 7. I get my final answer that x is greater than 7. To graph it, I put down a mark at 7, and I want all values to the right of 7. For the second one, this is the quotient. Quotient is division. The division of w and -15, so let's write that. W divided by -15 is greater than or equal to, so greater than or equal to 3. So when I translate, it looks like that. Now I need to solve. Multiply both sides by a negative to undo the division. This -15 and that -15 will make the number 1, cancel each other out, so I get w. And then when I multiply both sides by a negative, my sign needs to change. This needs to be a less than or equal to -45. Graph it, put down -45 as my key point, circle around it. I need all the values to the left. And then I go and fill in -45 because it says or equal to. So the last part you have to be able to do is translate from English to math and then solve using the tools we did from the first part of this section. Last part is I'm just going to give you a chance to try. So last one on the whiteboard, last slide for the lesson. If you would, pull out your whiteboard, and let's say, again, minute and a half should be plenty of time. You try these 2 questions, check with a neighbor, and then we'll go over it. And if you can do those, you should be successful in this section. First one says translate the product of -5 and y is less than 50 to an inequality and then solve it. This one's already been translated. I'd just like you to solve it and then graph it. So pause the video now for a minute and a half. Unpause it once everyone's had a chance to try. Okay, here we go. Here's the first part. It says the product of -5 and y. Product means multiply. So this is -5 times y. Then it says is less than, so less than symbol, 50. When you translate, it looks like that. Now I need to solve. Divide both sides by a -5. When I divide by a negative, I need to change the sign of my inequality. I get y has to be greater than -10. So I put -10 down, open circle around it. I can pick any value to the right of -10. I can get -9.9999 all the way up to positive infinity. Any number in between that range would make a true statement. Last one's already been translated. How do I undo dividing by 9? I multiply both sides by 9. I get v and I get 18. Do I have to change the sign? I do not. When you multiply or divide by a positive, those don't change signs of numbers. They won't change the sign of your inequality. So this one is I just want all numbers that are less than 18. Any number less than 18 would make a true statement. And there you go. That is it for section 2.3 in the notes. Hopefully you noticed it's really just a review of solving equations. You just have an inequality direction sign in the middle to worry about. As you're working, answers for section 2.3 are right here. If you'd like to leave the video paused to it, you could. And then your task would be to try the problems in class. I'd have a good feeling you could get most of it done in class. Oops. And I'm trying to get the screen just a little larger for you to see. There we go. You can leave the video paused to here so you can check your answers as you work, and then circle any ones you have a question about, ready to ask me tomorrow. So that is it. Thank you very much. I hope you had a good day.